Good morning, Year 5, and welcome to your Thursday maths lesson. We are going to start with our mental maths questions, which are on the screen now, and have a go at trying to recognise what the name of the shape is in the top right-hand corner. As always, give yourself around 30 seconds once you've paused the video, and then we will go through the answers. Pause the video now. Question number 1, a recap of yesterday's learning. Add together 3/10, which is the same as 0.3, and 5/10, which is the same as 0.5. Adding these together would be the same as 0.8 or 8/10. Question number 2, write 68 over 200 as a percentage. We know from our percentage lessons that percentage means parts per 100. At the moment, our denominator is 200. I've got to get my denominator to be 100. So to do that, I need to, what operation have I done to get from 200 to 100? I've divided it by 2. So if I've divided my denominator by 2, I must do the same with my numerator. 68 divided by 2, or half of 68, would be 34. Because my fraction is now over 100, I can use the numerator as my percentage, which means that this original fraction as a percentage is 34%. Question number 3. Round 6.43 to the nearest tenth. So to do this, I need to look at the hundreds column and work out, am I rounding to 6.4 or am I rounding to 6.5? Because the digit in the hundredth column is less than 4, I need to round it to 6.4. It's closer to 6.4 than it is to 6.5. Number 4, what number is 5 less than 2? So it's a recapping of negative numbers. So starting with 2 in your head, you're counting back 5. So starting with 2, 1, 0, minus 1, minus 2, minus 3. So minus 3 or negative 3 is the answer we're looking for there. Finally, the shape in the top right hand corner there is an isosceles triangle, because we've got two sides of equal length. We know that because it's represented, it's got these lines on it, which means the sides are of equal length. So it's an isosceles triangle. Let's get into today's lesson then. Our what, as it says at the top there, is to subtract decimals within 1. So yesterday we were looking at adding decimals using several different representations. Today we're going to do the same for subtracting decimals. And again, like we said yesterday, a lot of these skills are hopefully going to be able to be applied using your mental methods. But to help you do that, you've got to be able to picture the number line or the place value grid or the part whole model to allow you to be able to do this. There are some questions where you'll have exchanging, and like I said yesterday, it's always good to use the formal methods when you look at these examples. I'll show you one in a little bit. We'll start with the question 0.7 or 7/10 subtract 0.3. or 3/10. To represent that, I'm going to do it on a number line again. I'm going to represent 7/10 on a number line like this. I'm going to have a second number line where I'm going to represent 0.3. So what I need to do is I need to take off this amount and take off 0.3 from 0.7. So to do that, I can drag it over the top like so, put a line through it because I'm subtracting it, and you can see that what I have remaining is 0.4 or 4/10. Again, in your head mentally, that should be something that's quite quick. 7/10 take away 3/10 is 4/10, or 0.7 take away 0.3 is 0.4. If you can't do that quickly in your head mentally, then that's what you need to be using, visualizing that number line or those number lines in your head. Yesterday we also had a look at part-whole models, which we use to represent our addition calculations. We can also use part-whole models to represent our subtraction calculations. So I've put one on the screen here. Do you know what it's showing? What it's showing is I've got the whole, I've got 0.08, and I've got one of my parts, which is 0.02, and I'm looking for the difference between, because we said that the two parts make up the whole. So to find the missing value, I need to find the difference. So 0.08 or 8/100ths, take away 0.02 or 2/100ths would give me 0.06. Or, as that would be written as a fraction, 6/100ths. These two parts, if I use the inverse to check my answer, these two parts, do they add up to make the whole? 0.06 and 0.02 does give me 0.08. So I know my answer is correct. We can also, if I just get rid of this off the screen, we can also show subtracting decimals using a place value grid. So let's pull up a place value grid. And the example I'm going to model for you using the place value grid is 0.35 subtract 0.12. Let's start by representing 0.35 in my place value grid. I've got 0 ones, 3/10 I need, and I need 5/100. 2, 4, 5. I want to subtract 0.12, which is the same as 1/10 and 2/100. So I'm using my place value knowledge from my previous lessons to understand the value of the 1 and the value of the 2. I'm going to start by subtracting my hundredths. I said I've got 2/100ths in my 0.12, so I'm going to subtract, I'm going to take away 2 of my hundredths, which leaves me with 3/100ths remaining. I'm going to subtract 1/10 now, because I've got a 1 in my tenths column, and that's what I'm taking away. So I'm going to cross out one of my tenths, which leaves me with 2/10 remaining. I'm going to ensure that I put my place value holder and my decimal point in, which gives me the answer 0.23 or 23/100. Those examples will help you with the first couple of questions on the worksheet today. So you'll have a little look at number lines and a little look at place value grids and using those representations to help you subtract decimals. We are going to have a look now at another example, and we're going to use this time the place value grid because that's really, really important. But alongside the place value grid, I'm going to actually write the calculation using the formal methods, because the place value grids help you visualize the calculation. The column method actually helps you understand what it looks like when you're writing it down, because you might not always have this representation to show you. The example we're going to have a look at this time is going to be 0.26 subtract 0.21. Put my decimal point in before I start, make sure I put my subtraction symbol in. So I'm going to represent 0.26 on my place value grid. No, not, again in my ones column, so that means no ones, 2/10 and 6/100. 2, 4, 6. 6/100ths take away 1/100th. I represent it down here. will leave me with 5 remaining hundredths. 2/10 subtract 2/10 leaves me with no remaining tenths. So I would put 0 in my 10th column using my column method. And 0 ones, take away 0 ones, will leave me with 0. It's important I put my place value holder in. So 0.26 subtract 0.21 will give me 0.05 or 5/100, which you can see are represented here. So far, so good. We're going to have a look now at a slightly more complicated example. Again, I'm going to use the place value grid. I'm also going to use my column method because we're using them side by side now, and I'm going to give you a calculation slightly more difficult. So this time I'm going to have a look at 0.31, and we're going to subtract 0.15. Decimal point in, 0.31, 0 ones, 3/10 and 1/100. Now we have a problem in as much that I have 1/100 here, but I need to subtract 5/100 from that. So to do that, we do something called exchanging, which we're hopefully quite familiar with. So I'm going to exchange one of my tenths. Let's use this one. I'm going to exchange it 1/10. If you think about that 100 square that we looked at during the 10th lesson, 1/10, one row of 10 squares, is the same as 10/100. So I'm going to exchange that 1/10 for 10/100 because these are both the same. 2, 4, 6, 8, 10, just about squeezed in. So representing that on my column method calculation up here, I now no longer have 2/10 because I've exchanged, I've used one of them to exchange it for some hundredths. So I don't have 3 now, I have 2 remaining, 2/10 remaining, and I don't now have 1/100th. I've exchanged 1/10 for 10/100. I already had one there, so I've got 11/100 in total. So we've performed an exchange. Can I now do, if I go back to a different colour, if I now go back to my calculation, 11/100 take away 5/100, can I do that? Yes, I can, because I've got more counters. So subtract 5, 1, 2, 3, 4, 5. That leaves me with 6/100 remaining. So my 6 goes in my hundredths column like so. 2/10 subtract 1/10, cross out 1/10. How many do I have remaining? I have 1/10 remaining. 0 ones, take away 0 ones, remains 0. So my calculation, 0.31 subtract 0.15, gives me the answer 0.16. So today you're going to have a few calculations where you've got some exchanging to be doing. Remember, 10/100 is the same as 1/10. The last thing I want to show you before you go away and start the lesson this morning, I just get rid of all of these things, is finding the difference when looking at hundredths and tenths. If I wanted to find the difference between 13/100 and 3/10, 13/100 will be written as 13/100. 3/10 will be written as 3/10. 3/10, if you think about that 100 square again, 3/10, so 3 complete rows or 3 complete columns, is made up of 30 hundredths. So 3/10 is equivalent to 30 hundredths. I can now do 30 hundredths subtract 13 hundredths which is what I have at the beginning up here, which will give me in total 17 hundredths. So back to my original question, what is the difference between 13 hundredths and 3/10? By using a conversion and using my understanding of fractions, I found out that the difference between those two amounts is 17 hundredths. I could have used my decimals to help me do that. So I could have said, well, I know that 13 hundredths is the same as 0.13. I know that 3/10 is the same as 0.3 or 0.30. And once exchanged, I've just done some exchanging a minute ago, it would have given me 17 hundredths. So I've done it using my decimals and I've done it using my fractions. 0.17 and 17 over 100 are equivalent. They are the same, just represented in different forms. So your job today is to have a go at subtracting decimals within one using number lines, using place value grids, using or looking at calculations using exchanges. Let us know how you get on, and I will see you tomorrow.